So the next group of problems, 13 through 18, all have equal signs. These are the problems that kind of come from section 1.8. My goal for all the problems that are on the sheet right now is to get the left side factored and the right side 0. If I have the left side factored and the right side 0, then I can just set the insides of the parentheses equal to 0 and solve. If I don't have the right side 0, factoring is no good. If I don't have the left side factored, I'm not in a good place. But of all the problems between 13 and 18, 13 is perfectly set up. It's like the beginning problems from section 1.8. Left side is factored, right side is 0. And every single problem from section 1.8, ultimately that's my goal, to get the left side factored and the right side 0. If I can get that, I can then take the factors and set each one separately equal to 0. The factor of x plus 2, to get the x solved for, I'm going to minus 2 from both sides, which I'd probably do in my head. The factor of 3x plus 24, I'd still probably do in my head, but if I couldn't do it in my head, I'd minus 24 from both sides, and then divide both sides by 3. On the left-hand side, the 3's will cancel and be left with an x. On the right-hand side, 24 divided by 3 is 8, but a positive divided by a negative is a negative. For 13, my answer is x equal to negative 2 and x equal to negative 8. When I did the video for section 1.8, I checked a bunch. It's a good idea to check. It just, the videos get so long that I try to, balance between length and giving you everything I want to say. The next chunk of problems I've got to factor because they're not factored and the right side is 0. For problem 14, I'm looking for numbers to factor that multiply to negative 18, that add but really subtract to negative 7, and 14 I can sight factor because there's not a number in front of the x squared. So I'm going to lead off two parentheses with a couple of x's and equal to 0. And the numbers I'm searching for, this is a minus minus. I need a plus and a minus. The small number is a plus. And for 18, my choices are 1 and 18, 2 and 9, and 3 and 6. So my choices would be positive 1 and negative 18 because those multiply to negative 18. Positive 2 and negative 9. Those multiply to negative 18. And positive 3 and negative 6. Those multiply to negative 18. I left a gap between the 2 and the minus 9 because if I do 2 plus minus 9, which is the same as 2 minus 9, that'll give me the negative 7 that I need if I get this to show up. If I do 2 minus 9, I get the negative 7. So the numbers that are going in my parentheses, one of them is going to get a positive 2, the other is going to get a minus 9. You could have the parentheses flip-flopped. You get the same answers. Your answers will be flip-flopped too. From this point, now that I have it sight factored, I could get the answer without doing any algebra, and you shouldn't do any algebra. You should be able to just look at this and know what the answer is. But if I can't, the factor of x plus 2, I'll minus 2 from both sides and get one of the answers of negative 2. And the x minus 9, I'll add 9 to both sides and get an answer of 9. So usually when I write my answer, I write one of the letters, and if there's more than one answer, I separate the individual numbers with commas. 15, I need to factor. The left side isn't factored, the right side is 0. I'm going to factor by grouping because of the 5 as the lead coefficient. So in 15 to get started, I'm going to multiply the 5 and 3 and get 15. I'm going to search for numbers that multiply to 15, that add, it's actually a real add, to negative 8. And this is the second row of my template. When I have a minus plus, I'm looking for double minus numbers. So I need double minus numbers that multiply to 15. Those are my only choices. So my choices would be minus 1 and minus 15. those are double negative, they multiply to 15. And minus 3 and minus 5, those are double negative, they multiply to 15. I need the pair to really add because the signs are the same, they don't really subtract. Negative 3 plus negative 5, I think is the pair that I need. The negative 3 plus negative 5 part of this add up to negative 8. So I'm going to break up the negative 8x into negative 3x plus negative 5x. And I'd probably rather write that negative 3x minus 5x plus a negative is always the same as a minus. So I'm going to rewrite the problem on the left-hand side. I'm going to have 5x squared minus 3x minus 5x plus 3. And I'm going to go into grouping. Anytime I have three terms and the lead coefficient, the number in front of the square term, isn't 1, I factor by grouping. Still have this equals to 0 on the right-hand side that I should tend to. On the left-hand side, first parentheses, I'm going to pull out a common factor of an x and be left with a 5x minus 3. Second parentheses, the first term is a minus. I need to factor out a minus. There isn't a common factor, and when there isn't a common factor, I need one. I'm going to write a 1 as my common factor. Inside my parentheses, because I factored out a negative, I switched the signs. The negative's going to turn to positive. Because I factored out a 1, nothing else is going to change. So the positive in front of the 3 is going to turn to negative, and I factored out a 1, so the 3 is going to stay the same. Now I'm going to get my factoring done. I'm going to get a 5x minus 3 for one of my factors. It could be written first or it could be written second, times an x minus 1. Because of the equal sign, I need to get numerical answers, which you might be able to get in your head, but if you can't, this is the math. I'm going to set the 5x minus 3 equal to 0. I'm going to set the x minus 1 equal to 0. For the 5x minus 3, to get the 3/5 answer, I'm going to add 3 to both sides and get 5x equals to 3, and then divide by 5, divide by 5. That's going to give me one of the answers, which is 3/5. For the x minus 1, I'm going to add 1 and add 1. That's going to give me the other answer of 1. So the answer for problem 15 in either order is positive 1 and positive 3/5. I can check these, but I don't have to, but I probably should. If I wanted to check the 3/5 because it's a fraction answer, I would just do this. I'd go 5 times parentheses fraction 3/5, get out of the denominator parentheses squared, minus 8 times parentheses fraction 3/5, get out of the denominator, close my parentheses, plus 3, and my answer is only right for the 3/5 is only right if when I hit equals I get 0 because the right side is 0, and it is. Similarly, if I wanted to check the 1, I'd go 5 times parentheses 1 squared minus 8 times parentheses 1 plus 3, and when I hit equals, if I get 0, that's right, and I do. I like to sneak 16 on my practice test. I usually don't put something exactly like it on a test. I'm sorry, 18 is the one. 16 I put on the test. It's something that's important. 16 is on the test. 18, oh, maybe it's a little tricky for the test, but I like to sneak it in because it comes up every now and then as we get further. In 16, the answers aren't 0 and 3. A common factor with an x only gives a solution of 0 if the right side is 0. A factor of x minus 3 only gives a solution of 3 if the right side is 0. In 16, because the right side isn't 0, I need to go through the steps, and oh, maybe I still have those around here somewhere. I don't see those steps. They got trashed along the way. The steps for solving when the right side isn't 0 is I'm going to clear the parentheses and combine like terms. to get started. So in these problems from section 1.8, if the left side is factored and the right side isn't 0, that's the bottom problems. And the steps that we had to go through is to first clear the parentheses. If there were any like terms, because maybe I had to FOIL, I'd combine them. And then we set equal to 0. So in this problem, I've cleared the parentheses. There weren't any like terms. I'm going to set it equal to 0 and get x squared minus 3x minus 10 equals to 0. Then I'm going to factor. I'm going to sight factor the left-hand side because there's not a number in front of the x squared. The numbers that I need to factor problem 16 need to multiply to negative 10, add, subtract to negative 3, and they're going to be 2 and negative 5, because 2 times negative 5 multiplies to negative 10, and 2 plus negative 5 is the same as 2 minus 5, which is my negative 3. So one of my parentheses is going to get a positive 2. The other parentheses is going to get a negative 5. Should be able to write the answers down, but if I can't, I'd go x plus 2 equal to 0, x minus 5 equal to 0, get into the second to last step of solving. The x plus 2 equal to 0, I'm going to minus 2 from both sides and get an answer of minus 2. The x minus 5 equal to 0, I'm going to plus 5 from both sides and get an answer of 5. I think the answers are negative 2 and 5. That's a solve, believe it or not. But I should probably check just because there's a lot going on here. And for checking, I should go to the original problem, x times x minus 3. Make sure when I plug my numbers in individually that I'm left with true statements, so that when I plug negative 2 in for x, both sides come out to be 10, and when I plug 5 in for x, both sides come out to be 10. I like the calculator check if I'm going to take the time to check. So checking the negative 2, I'd go negative 2 times negative 2 minus 3. This gives me 10 equals to 10. I know that that's good. And checking the 5, I do 5 times 5 minus 3. That also gives me 10 equal to 10. So I've successfully checked these, even though I almost flew off the screen. 2 more than some word problems. 15 and 17 are almost the same style of problem in that I'm going to have to group factor. In 17, I'm going to multiply the 5 and the negative 2 and get negative 10. I need to find numbers that multiply to negative 10, that add, but it's really subtract, to be positive 3. Big number plus, that would come from my template here, plus minus. I need a plus and a minus, big number plus. My choices to multiply to negative 10 would be 10 and negative 1, those would multiply to negative 10. 5 and negative 2, those would multiply to negative 10, big number plus. The ones that I need are the 5 and the negative 2, because if I add 5 and negative 2, that's the same as 5 minus 2, which is going to give me my 3, which means the 3x in the problem I can write as 5x minus 2x when I go to factor by grouping, but I'd rather write it minus 2x plus 5x. So I'm going to factor the left side by grouping because I can't sight factor when there's a 5 in front of the x squared term. I'm going to make this 5x squared minus 2x plus 5x minus 2. I still have the equal to 0. Introduce my parentheses. The first terms in the first parentheses, they both have an x. I'm going to factor out an x and be left with a 5x minus 2. second parentheses, there isn't a common factor, so I'll factor out a 1 and be left with another 5x minus 2. Finish up my factoring. I get a common parentheses for one of my factors. What's in front of the common parentheses for my other factor? I can write the answer from here, but if you can't, once you get the left side factored, I'm going to set each of the factors equal to 0. The factor of 5x minus 2, I need to do 2 steps if I'm not doing this in my head. First step is to add 2 to both sides, and that will give me 5x equal to 2. And then divide by 5. On the left-hand side, the 5's will cancel. On the right-hand side, I get the fraction 2/5, which I can check on my calculator if I care to. And the x plus 1, I'd minus 1 from both sides and get a minus 1. So in terms of an answer for 17, my answers are 2/5 and -1. 18 is supposed to be similar to problem 13 in that the left side is factored, the right side is 0. When I looked at 13, it was obvious to me that I could jump straight into getting my answers. 18, maybe it's not so obvious, but for each of the problems on this sheet, my goal is to get the left side factored and the right side 0. Once I have the left side factored, the right side 0, I can go into getting answer mode. The only time I destroy the parentheses if there's factoring is when the left side is factored and the right side isn't 0. Problem 18 isn't really like problem 16 because of the 0 on the right-hand side. Problem 18 is really more like problem 13. Problem 18, the left side is factored, the right side is 0, so I could go straight into getting my answers. The 2x is a common factor with an x. Common factors with x's give solutions of 0. I can get that solution manually by dividing both sides by 2. On the left side, if I divide by 2, I get x. On the right side, I get 0 over 2, and fractions with 0 in the numerator equal to 0. The x plus 4 factor, I'd minus 4 from both sides and get an answer of -4. So for problem 18, my answers are 0 and -4. I shouldn't clear the parentheses. The only time I clear the parentheses when there's factoring is if the right side isn't 0. So 2 word problems to do. And we did a couple bedroom rectangle word problems and a couple garden rectangle word problems. This is the more complicated wording. There was another wording that said more, and the test might have the alternate wording. But the first sentence in problem 19 really says, it says a rectangular garden is 2 feet narrower than it is long. This means the width is 2 less than the length. So that first sentence, it was written poorly or written oddly in the section. I kept that wording. The first sentence will say the width, W, is equals, less than is a subtraction, and I switch the order. The 2 comes first, the length comes second. It's the length minus 2. So in this particular problem, the W is the width of the garden. And it's going to be in feet. The length, the L is the length of the garden. I'm not going to write of the garden in feet. But the first sentence in its abstract way tells me the width is length minus 2. The second sentence says the area is 35 square feet. And I know the formula for the area is length times width. So the second sentence basically says A, which is area, is, says the area is 35 square feet. And I know because this is a rectangle that area is length times width. And I know that for this problem, and for that W, I can put length minus 2 because for this first sentence, it tells me how to replace the W with something that has an L. So this is the equation that I need to solve. It's going to give me two answers for the length of this garden. Gardens can only have one length. One of the answers is going to be positive, the other is going to be negative. I'm going to throw out the negative. I'm going to clear the parentheses on the left-hand side to help myself get solved. I'm going to multiply the length times the length and the length times minus 2. That's going to make L squared minus 2L come up on the left side. And I get 35 on the right side. Now I'm going to minus 35 minus 35. So it's going to give me L squared minus 2L minus 35 equals to 0. I'm going to sight factor the left-hand side. I'm going to need to find numbers that multiply to negative 35. 1 plus and 1 minus, that add but really subtract to negative 2, and I'm going to load those up for my parentheses. And that's going to be 5 and negative 7, because 5 times negative 7 is negative 35. 5 plus negative 7 is really the same as 5 minus 7, which is negative 2. So in one of my parentheses, I'm going to get a plus 5. The other parentheses, I'm going to get a minus 7. If I can't get the answers by inspection, then I should go L plus 5 equal to 0, L minus 7 equal to 0. For the L plus 5, to isolate the L, I'll minus 5 from both sides, and I'll get negative 5. That one's not possible. I can't have a negative length of a garden. The L minus 7, to isolate the L, I'll add 7 to both sides, and that will give me an answer. When I go to write my answer, I need to put units in. That 7 that just came up, I'm going to put the unit feet. So part of my answer is 7 feet. And then, because it says the width is 2 less than the length, I'm just going to minus 2. I'm going to say the width is the length minus 2. So the width is the length 7 minus 2, which is going to be 5. So my width is going to be 5 feet. Done. And it fits perfectly because the area of a rectangle is length times width. If I multiply the 7 and 5, I get 35, and they're 2 apart. If on a test question, this was a 5-point question, you didn't have any algebra, and you write an answer, I'm going to take 3 points off at least, maybe 4 points off. The algebra is more important than the answer. Problem 20 is a right triangle. And in the world of right triangle problems, I generally draw this triangle. The hypotenuse, I give a C. It's across from the right angle. The vertical side, I call A, and I call that the short leg. The horizontal side, I call B, and that I call the long leg. And right triangles obey the Pythagorean theorem, a squared plus b squared equals c squared. As I read through, each sentence is going to help me get an equation. The first sentence says the hypotenuse, which is c, in a right triangle, is, which is equals, is 5, and it doesn't say anything after the word inches. There's not a word like more or less, so it's not going to have a plus or a minus. The first sentence just simply says c equal to 5. The second sentence starts off with the longest leg, which is b, is, which is equal, and then 1 inch longer, that's going to be a plus, than the length of the shortest leg, which is a. So it says the longest leg is 1 plus the shortest leg, and I'd write that as a plus 1. Longer is adding, shortest leg is A, adding 1. So it says the longest leg, B, is the shortest leg plus 1, or 1 more than the shortest leg. Then it says find the length of each side. I know that the C is 5. This is probably a 3, 4, 5 triangle. But I'm going to use the Pythagorean theorem now of A squared plus B squared equals C squared. I'm going to leave the A squared alone, but in place of the B squared, I'm going to put A plus 1 squared because B is A plus 1. And in place of the C squared, I'm going to put 5 squared. I'm going to start simplifying this. The A plus 1 squared I can write as A plus 1 times A plus 1. That's going to be A times A, which is A squared. A times 1, which is plus 1A. 1 times A, which is plus 1A. And 1 times 1, which is plus 1. This comes out to be A squared plus 2A plus 1. I still have the equals 5 squared, and I still have this A squared to bring down. I'm going to bring this A squared down, put a plus sign after it, sneak a couple 1s in front of my A squareds because it's going to help me combine, and the 5 squared I'm going to get to be a 25. So now I'm going to combine the A squareds on the left-hand side. 1A squared from this A squared, the other A squared from the parentheses are to combine to be 2A squared. I still have the plus 2A. I still have the plus 1 equals 25. I'm going to set this equal to 0 by minusing 25 from both sides. This is going to give me 2A squared plus 2A. 1 minus 25 is minus 24 equals to 0. I'm going to take this 2A squared plus 2A minus 24 equals to 0. I'm going to factor out a common factor of a 2 and be left with A squared plus A minus 12 equals to 0. And I'm going to sight factor. I'm going to make 2 parentheses. The A squared doesn't have a number in front of it, so I can sight factor. I'm going to lead my parentheses with a couple of A's. The numbers are going to need to multiply to this negative 12 and add, but really subtract to the 1 that's implied in front of that A. And that's going to be 4 and negative 3, because 4 times negative 3 multiplies to negative 12. 4 plus negative 3 is really the same as 4 minus 3, which is 1. So in my sight factoring, one of the parentheses is going to get a positive 4, the other is going to get a minus 3. Now I'll go to get my answers. Common factors without an x don't give a solution, so I'm going to ignore that too. The factor of a plus 4, when I set it equal to 0, I'll minus 4 from both sides and get a equal to negative 4. Dimensions or length of legs in triangles can't be negative, so I'll ignore that one. And for a minus 3, when I set it equal to 0, I'll add 3 to both sides, and that will give me a equal to 3. That's going to be one of the 3 answers that I need. Triangles have 3 legs. I'm going to write the length of each. First I'm going to do is a equal to 3. I peek at the dimensions. I'm going to get inches. Then I'm going to find the b. I wrote down to myself somewhere at this that b is a plus 1. So b is going to be a plus 1. So it's going to be 3 plus 1. And b is going to be 4 inches. And c was given at 5 inches. I don't really need to give it again, but I'm going to give it anyways. The triangle has 3 sides. I like to give all 3 sides, even though one of them was given. I don't need to really probably write down something that was given. So that's everything for the Chapter 1 practice test. It has 20 questions on it. Sometimes when I write the Chapter 1 test, I don't put the triangle word problem and I make the test have 19 questions. But be prepared for 20 questions with 2 word problems just in case.